The next step is the actual brazing procedure. For purposes of demonstration, we shall braze a T-joint between brass and mild steel, and then we shall join copper to copper in a typical pipe joint. We will first demonstrate the brazing of the T-joint. The prepared and fluxed parts are set up using a suitable jig for support. A general-purpose silver-based brazing alloy would normally be used for this task. A neutral to slightly carburizing flame is used to apply the heat. To begin with, heat is applied broadly so as to preheat all surrounding surfaces. The steel section, being less conductive than brass, will require more heating. Keep an eye on the reaction of the flux on both surfaces. If the heat is evenly spread, then the flux will be reacting similarly on both plates. The metal is approaching brazing temperature when the flux turns into a clear, water-like liquid. At this time, the filler rod may be introduced to the joint, and if the temperature is correct, the filler alloy should melt and flow rapidly by capillary action into the joint. If, however, the temperature of the metal is too low when filler is introduced, the alloy will tend to blob and resist flowing. Control over the torch flame is an important factor when brazing. The flame is used to maintain the temperature of the metal and assist with initial melting of the alloy. But it must be remembered that it is the heat in the metal, not the heat in the flame, that causes the alloy to flow. Let us move on now to demonstrate the brazing of copper to copper, which typically is performed on copper tube joints. For this particular exercise, we will use a fluxless process involving the selection of a phosphorus-based alloy. Copper tubing is commonly brazed in position. However, for demonstration purposes, we will use a jig to support the work. As copper absorbs heat rapidly, it will be necessary to select a relatively large-sized nozzle in order to provide a broad area of flame. Preheating must be applied broadly over a large section of the tubing. Copper is ready to receive filler alloy when its color becomes cherry red. But as heat losses occur rapidly, the flame needs to become concentrated close to the area of application. Filler will rapidly run into the capillary gap when the temperature is correct. Moving the flame around the tube will encourage the alloy to flow throughout the joint. To ensure deep penetration into the joint, heat is applied beneath the point of application. This effectively draws the molten filler towards the heat and therefore more deeply into the join. After any brazing process involving the use of flux, there will always be an amount of flux residue remaining on the work surfaces. Failure to remove this residue will generally result in corrosion of the metal. If the residue is allowed to cool, then it will become very hard, requiring chipping and hard brushing with a wire brush to remove it. The easiest way to deal with flux residue is, after a short time of air cooling, to quench the work in warm water before the flux has had time to solidify. Light brushing or sanding may be required to remove surplus matter from the finished joint. Soaking or pickling in an acid solution can loosen stubborn residual flux and certain oxides. After some time of pickling, the work is removed from the pickling solution, rinsed in fresh water, and brushed or scoured in order to remove remaining deposits. Copper joints made without flux will have no flux residue, but will be coated with oxides that are easily removed by wiping and scouring. For appearance sake, if required, the metal may be cleaned using a commercial copper cleaner. Inspection of a joint is made easier when the residues have been removed. A good braze is neat in appearance, but more importantly, the filler material fully fills or penetrates the cavity. On a lap or a T-joint, this is evident by the fact that filler can be seen on the reverse side of the work. On pipe or tube joints, the filler must completely fill the cavity. Go now and practice the procedures involved in brazing using silver-based alloys in your place of work.